so feel free to make space for the others that come in as I walk through. So afternoon, we're in the home stretch, and we're going to end on a high note with these last two panels. So for those of you who haven't met me, I'm Stu DeQ. I lead the Yale Center for Business and the Environment, and 6 months ago, I also took on a new role leading something called the Planetary Solutions Impact Accelerator, which is the lab-to-market work that we do at Yale to support, enhance, fund, accelerate the work of faculty who are doing breakthrough research, and where do we turn that into early stage commercial work. And so it's been my privilege to kind of like lead and work with people across the university. And you can check out online, but we just offered 4 new awards under this program, $250K, milestone-based over 2 years. Really pleased that Noah is one of the folks that we're able to support this year, and I know you're going to get a chance to learn more and talk about his work. There are 3 other fantastic folks who received that as well, and their teams. We get to draw from across campus, right? This is from engineering and applied science. It's from chemistry, biology. It's from all the different departments and places around Yale who have fantastic and interesting work to do. And this is where we get to feature this in this panel with one of the centers of excellence at Yale that has really kind of defined and developed kind of programs, practices, research that is leading across the globe through the Yale Center for Natural Carbon Capture. And really privileged that Toby is going to be able to moderate and lead this panel, but really this wonderful blend of where you combining market insight with world-class research in a place where people can interact, engage, and push each other. And so they're a joy to work with. Thank you all for making the time for this, and looking forward to the panel.
Awesome. First of all, thank you very much, Stu, for that kind introduction, and many thanks to you and Josie and Julia and the team at CBay and at Yale Ventures for putting on this incredible event. It's really a privilege to be here. My name is Toby Bryce. I am the director of the Yale Center for Natural Carbon Capture. We're a philanthropically funded research center at Yale. We span departments and schools at Yale, as Stu alluded to. School of the Environment, which is our professional environment school, a number of different departments in the Faculty of Arts and Sciences. Noah is from the Earth Science Department. And then folks from engineering. David Quabi, who you'll meet in a second, is from the engineering school. And with the goal of translating research at Yale into real-world impact. And for us, real-world impact means real-world mitigation outcomes. We're focused on how you can enhance natural Earth systems to reduce atmospheric concentration of greenhouse gas and deliver climate mitigation. And we're really focused on solutions that offer benefits to farmers, to communities, to coastal communities, to ecosystems, because many of the things we work with, they're not going to be scaled by climate finance alone. Super excited for this discussion. We have 2 faculty at Yale and then 2 former Yale students who have started really important, successful climate tech companies. And so let's kick it off maybe just with quick intros down the panel. Tell us who you are, where you come from, what your Yale connection is, and how you relate to this idea of translating research at a university into real-world impact.
Thanks, Toby. Pleasure to be on this panel. My name is Connor Rooney. I'm the CTO and co-founder of Oxless Energy. We're a Yale spin-out. I did my PhD here, finished in 2024. Spun the company out from the research I was doing in the chemistry department on CO2 conversion to methanol. We're still based here locally in Brantford. Really excited to tell you about the journey from starting a company as a student, spinning it out, learning a lot, making a lot of mistakes, but hopefully making some, doing some good things along the way too. Eager to share.
Great. Thrilled to be here with everyone. I'm a professor of Earth and Planetary Sciences. I've been here for about a dozen years, and have taken leave a couple times from Yale to have companies leave Yale and to start companies. So I'm a geochemist, which people can take in different ways. But the main idea from it is just study chemical reactions in natural environments. And a lot of my research is thinking about how we can utilize existing infrastructure, utilize processes already do them better, and do it in a way that actually removes, by doing it better, in a way that reduces the greenhouse gas impact of the process we're doing.
Hello, everyone. My name is David Quabi. I'm an associate professor in the Chemical and Environmental Engineering Department. I've been here for a year and a half. I was a professor for a number of years at the University of Michigan before that. It's working? Okay. So my research centers around using electrical systems.
Maybe battery guy.
It's ironic because I work on batteries. So my research centers on using electrochemical systems, mostly batteries, and developing them for storing large amounts of renewable electricity on the grid, not in mics, unfortunately, and also thinking about using them as test beds for other processes that have to do with climate and sustainability, chiefly carbon capture, nitrogen removal from wastewater, and so on and so forth. So nice to meet you all. I'm looking forward to the conversation.
Awesome. Hi, everyone. So glad to be on this panel today, and thanks for joining us. I'm Mary, co-founder and CEO of Lithos Carbon. We are a permanent carbon dioxide capture company. We trap atmospheric CO2, take it out of the atmosphere, stored for thousands to hundreds of thousands of years, and our work is based on about a decade of research out of Yale University. So we're very, very lucky to have had that incredible foundational start here. We are about 4 years old. We've signed about $100 million in contracts with companies including Google, Microsoft, McKinsey, JP Morgan Chase, folks who are net emitters and are looking to suck CO2 out of the atmosphere and permanently trap it. And our work basically uses a waste byproduct, volcanic rock, which is also found in Connecticut. Believe it or not, there's volcanic rocks here. We spread a special kind of waste dust on farms, which sounds not very high-tech, but it actually ends up being quite high-tech in practice. And then it traps atmospheric CO2 in a permanent form that then gets sequestered. So really stoked to be here, excited to talk about what it looks like taking a decade of research from tiny little pilots and farms in Connecticut and the Midwest and other places, and then spreading that now. We've done about 2 NFL stadiums full of rock dust, so lots of rocks out in 10 states in America and some pilots overseas, and we're commercializing the technology today.
Amazing. Thank you all for those intros. So we're here at the Innovation Summit. Incredible event, a couple thousand people coming here to talk about innovation. And maybe I thought I would and we're going to have a discussion here, and then we're going to open it up for questions at the end. So please think of some questions to ask the panel. But maybe to start it off, David, I've heard you talk about this in a really interesting way. Since you started companies and you're also a research professor, how do you think about the different roles of a university lab and then a commercial enterprise, a startup, in terms of the innovation ecosystem?
Yeah, so I guess my perspective on this is that, university, the main charge of a university is to generate new knowledge, so to speak, right? A startup would have, the objective of a startup in general is to meet some sort of business or commercial objective. So those might seem disparate in some sense, but I think there are a number of ways in which universities and startups can and should work together. So one of them has to do with the types of questions that universities or labs choose to answer, right? Can, in principle, be informed by what's going on in the startup world, what's going on at sort of the frontier of commercialization of climate tech or other types of research. And I think universities can also be an interesting place to have sort of a test bed for technology that would eventually make it out into the real world. So figuring out ways to test and develop systems in the lab that would be relevant to how they will be deployed in the field is another way I think universities and startups can productively work together. And I can maybe give examples at some point about how that has broken down in certain areas in my field, for example. On the other hand, I do think it's important that universities retain this ability to be agile, and labs should feel free to sort of research and look at crazy ideas, right? Things that would maybe have a low probability of success but very high upside. There's a balance between those two perspectives, right? Because as the climate warms and as sort of this emergency continues to accelerate, we need to figure out, well, where does the equilibrium of social responsibility sit? How many crazy ideas we pursue versus the ones that are sort of, imminently going to make an impact. I think that's an important conversation to have, but that's how I see the breakdown. Yeah.
Super helpful. And Noah is the other professor on the panel, and you work obviously you work leveraging engineered systems, but you work more with natural earth systems. Do you have is there a slightly different spin on how you think about it, or different examples from your experience?
Yeah, I mean, in many ways would agree with Steven, so just kind of build on that. I think one of the things that maybe is more important when you think about how you're interacting with natural systems, how you're interacting with something like wastewater or agricultural systems, which are somewhere in between natural systems and very engineered systems, is that I think an important role that universities can play is having ideas that are going to be a step change, take us in something that's a totally new direction. I think there is a strong tendency, especially for the larger that entities get, to be doing practices that are very incremental. So I think universities play a central role in ensuring that the direction that we take isn't incremental, isn't tacking towards something that we know is not the optimal solution. So I guess, and I'm not just saying that because we're at an innovation summit, but I wasn't told to say anything about innovation at the innovation summit. But I think it is universities, we are going to have ideas that are truly transformative, that are disruptive. Something that is going to take us in a totally new direction in a way that I don't think even startups are going to, or at least not working without things that are building from work at universities.
Great points, both of you. And I've been at Yale for 2 years, and just the evolution and the advancing of the ideas just in the very short period of time that's happened here at Yale is really incredible and inspiring, and it's one of the things that kind of gets me up every morning to come to work. Would love to flip it to the commercial operators. Mary and Connor, both of you, maybe starting with Mary, could you just tell us a little story about how your company started, how you actually made this move from being a student working in a university lab to now CEOs and founders of thriving startups?
Yeah, great question, Toby. All right, just checking the batteries are working. Yeah, great question. So fundamentally, I think that the research and the commercialization parts really go hand in hand. And the research part is incredibly important because, as Noah said, driving the frontier forward, figuring out the edges of what's possible in reality, figuring out like how the costs might theoretically work, which, does really change as you commercially scale. And also building a robust sense for others in the market, let's say my customers, Google, Microsoft, et cetera, building a robust sense with published third-party literature that shows like, hey, this can work at some scale, it works at some scale. Here's some of like the edges, the limitations we're aware of. All of that is so fundamentally critical to building a new market. And I think that what Connor and myself and others coming out of Yale are doing is trying to build something first of a kind in a brand new market that's not been proven. And that's why it's so exciting. So for us, there's been a lot of tactical little things you can do that I won't bore you with it. But in our particular case, we had to find a lot more feedstock, right? At academic scales, you've got like a small little pile and you do some work. We have now moved to NFL stadiums of rock. So there was a lot of rocks to find, to test, make sure it's screened, it's going to be safe for communities, it's rich, nutrient rich, good for farmers, like lots of things that actually matter when you're working in real communities with farmers and a lot of lives and communities that are going to be stakeholders in this work, to a lot of tactical considerations, which I won't bore you with, but industrial logistics and supply chains, right? We often call ourselves internally at Lithos, we're like trying to be the Amazon of rocks, spread a lot of rocks that are really high quality for as low cost as possible so we can capture as much carbon as these corporates can afford. And so like lots of cost considerations and details like that come into the mix. But fundamentally, that is all really powered by the fact that the academic research and literature has actually helped establish a footing and helps some of these buyers pull forward purchases and believe that, hey, it's actually a good idea to give this particular startup a $10 million contract, even though they're like 5 people and there's, a dozen papers on this because we really believe this can scale. So it was a lot of balancing the act between translating scientific literature for buyers who do not read science, are usually in the economics or policy side of the world, and also so much industrial heavy lifting, because if you've got great research but you don't actually have a supply chain and a plan for scaling that, it's going to be a very long road. So we focused probably like 60 to 70% of our efforts after we got enough commercial demand on industrial supply chain, cost, logistics, because that's actually what it takes to build the company, get more data in the funnel, share that back with the academics, and help the industry grow. I'll say one more thing here before passing it on to Connor, which is I also think there's a really important handoff and continuous feedback loop that should occur between commercialization and academia. I think something really powerful here is that third-party independent validators and academic researchers are able to have take a different voice in the field and sort of credibly comment on, the state of things, where the edges of the next phase can be, what is actually good for communities, what's a good policy in a way that's not driven just by capitalism and profits, right? And as a climate company, we're fundamentally driven by the mission, but we do have a charge to like make all of the costs and numbers work. And so I think that's really powerful. And I think that the most powerful version of this relationship can be one where there's data, feedback loops, some sort of collaborative work that can be done that helps the whole field move faster and accelerate instead of being like walled off. So that's a personal take that we have here at Lithos.
Yeah, I think that's really insightful. I think Mary kind of captures right there the difference between the mindset of, a kind of commercial operator and, the academic work, in that, as a commercial operator, it's about the customer, right? So, the customer and the cost, right? Ultimately, that's the most important thing, and that's what the customer cares about. And, being a technical operator, having been a graduate student not too many years ago, I remember, look back fondly on being a graduate student tinkering in the lab, and I don't think I thought about the customer a single time. It's just a total mindset shift. And the priorities in the work do, change significantly, right? And the most important thing, that I learned, starting the company and that great mentors, here at Yale and outside, kind of really hammered home for me is like, go talk to, the people that are going to buy this technology, learn what they want, like what the pain points are, and then figure out how your technology addresses it. And what we learned, what I learned is that, the things that we cared the most about in the academic lab, which were really important to kind of push the frontiers of science, were not necessarily the same things. There was some overlap, but there were some things that were just totally different. If we had just kind of kept our heads down building on like what we had done in the research lab, it would have been the wrong product, right? And you kind of, I guess the famous saying is, you have a hammer and you're looking for the nail, and really you want the nail first, and then you build the hammer that, hits that nail, right? And so that's, I think, the big mindset shift. And if I can kind of, maybe add some spice to the panel here, I think, there's certainly a lot of talk, I think there's a lot of information flow from academic labs to startups, right? Because often that's the transition that folks take, professors and folks like the four of us from academia into the startup world. And I think there should be more of that, reverse, that loop. And a lot of it happens, and obviously, the two professors on this panel are like excellent at doing this. But I think there could be more of that because the priorities that you learn, it shouldn't form all research, right? We want the crazy ideas, but we've learned a lot of things building our CO2 to methanol technology, where I think about, okay, for example, we operate our reactors, at low temperature, but it's below the temperature of boiling water, 50, 60 Celsius. But almost all the academic research in our area is at room temperature. And, in the academic world, room temperature is like, oh, that's what we should run at. But actually, you need to run at 50, 60 Celsius in the commercial setting because these things self-heat. But that, knowledge from the commercial operator perspective hasn't really filtered into academia, and it would be much more beneficial, and the commercialization journey would be faster if it had. So that's just like an example of where I think a feedback loop would be, pretty beneficial.
And a really good point. And I can speak from a Yale Center for Natural Carbon Capture perspective. We're thinking about implementation and scaling of the things that we work on. So we really do think about things need to be financially operable, commercially operable, they need to be engineerable. But David and Noah, how does this manifest in your thinking? What have you learned from, you're both experienced professors now, but from being a new professor, as you've started companies, what are some of the things that you've learned, speaking to Connor's point?
I mean, I can give multiple examples kind of illustrating exactly what, Connor's trying to bring out here. Maybe just a little example to color things a little bit, right? If you walk into my lab, you'll actually see us testing flow batteries. So flow batteries you can think of these as really large vats that are storing chemicals, which are storing your energy. It's sort of a simplified way of putting it. But if you walk into my lab, you'd see us testing these batteries inside these big glove boxes that are filled with nitrogen, so oxygen-free glove boxes. And the reason is because these chemicals in some certain states can be vulnerable to oxygen, which like, obviously exists in air. And so one of the problems that people in my field have been trying to solve for a while now is how do we make these chemicals invulnerable to oxygen, which is really challenging to do because thermodynamically, actually, oxygen is just going to oxidize it, one of the chemicals when it's in a certain state. But then I had a conversation with the CEO of a company that actually spun out of some of my postdoc research, and I was like, "How are you guys, trying to solve this oxygen problem? Because everybody's trying to solve it in the lab." And he's like, "Oh, actually, industrially, like these vats are so huge, the headspace is so little, there's just so little oxygen that you can just take a small hit in efficiency and keep working." Right? And maybe about a couple of weeks after we had that conversation, there was a paper in Nature that was like, "We solved the oxygen problem." So I think that the sort of the closing the loop between academia and sort of the commercial world and startup world, this is a really important point. And I don't know how one can go about doing it. I think we need sort of a cultural, social change because the impetus is for what's new. Well, have you solved this problem that we all think is important? As opposed to we need to run our flow batteries at 50 degrees rather than room temperature because that's more important for running them in the real world. So,
well, I don't know if this will exactly answer your question, Toby, but to shift and build a little bit on that. And I guess even though Connor's comment was meant to be spicy, to just say, to remove that spiciness and say, I actually totally agree. That's too many spices. But I think one of the things on that that's thinking about how do we move from this, moving forward, how do we have this exchange be faster, I think is we at a university don't do a great job of hosting people that are coming from universities. So we often think of faculty members love our sabbaticals. Yale has a generous sabbatical program, and sometimes we use them in useful ways, once in a while. But what we don't do as good of a job of is actually taking people that are out in the world, they're actually out and doing things, and bringing them to Yale. And that's something I think that is where, if you think of what we invest in, something that if and what we prioritize for funding, something that could really make a big difference in it. But yeah, and even though I just made fun of sabbaticals, in case any administrators are actually listening, they're really important. I do actually. One of the sabbaticals that I took was spent a lot of time with a large a guy that runs a forestry operation, large farming operation in Virginia. To the point we ended up renting a double wide from him because we were down there long enough, and it was a case where realized that from the idea of how you're running a large scale forestry and agricultural operations, I had so many gaps in my knowledge of what that actually looked like that made me do a lousy job of translating what we were doing at a very controlled, small scale into something that actually worked. So I think, and part of it is things that academics are not good at is humility. part of it is realizing that a grower in Virginia knows a hell of a lot more about growing in Virginia than I ever will, and being able to be open to that, I think, is really important.
Connor, can you talk a little bit about, your company was spun out of Yale Research. You still have kind of an ongoing relationship with Hailing Wang, who's the professor that you worked with who kind of invented that technology. Can you talk about how your commercial scaling and implementation relates back to research, how it feeds back? Like, you gave some examples maybe, but like, how are you informing the work that's happening in Hailang's lab, and how does that help you advance your business?
Yeah, no, it's an important question. And so, maybe I can talk a little bit more, give the context of kind of the technology we have to sort of inform this. So, the initial discovery at Yale was a new catalyst, a new material that's really good at converting CO2. And it was published in Nature, and I was a wide-eyed graduate student, first-year graduate student when that got published. And I spent, the next 5 years kind of focused on, understanding this material, trying to tweak it to make it better. Around year 4, I finally kind of poked my head out of the lab and was like, okay, what am I going to do next? And, at that point, I started spending time at the Center for Entrepreneurship at Yale, actually wearing my Sci-City socks today. I got in the summer fellowship that year, so it was kind of, I think, before my 5th or 4th year of my PhD, and we got a little bit of funding to kind of explore what a commercial application would look like, talked to a bunch of customers, met my co-founders who were business school students at the time, and we formed a team, started Oxalus Energy, and at that point, we started to build a techno-economic model, right? Understanding like, okay, what are the key metrics that matter? How does this material discovery translate into a commercial product? So we kind of understood, okay, we need to build a reactor around it. And that's really been the work we've done at Oxalus is, okay, based on the techno-economic assessment, what the customers want, how do we, translate this material discovery into a product, into a reactor? And so we've been testing the material in, these kind of reactors. And one example, like I gave, is we operate them at higher temperature. And so that's actually been something, very lucky that Hailang is a scientific advisor. He's a professor here in the chemistry department. He's continuing to do research that's really helpful for us. And, we talk frequently and we share kind of insights back and forth. And we actually just got a grant from Department of Energy, ARPA-E. That's a $3 million award with Yale to have 2 students here that will be full-time working on translational work. So we're really excited about that. And so it plays a very important role, the academic research, and especially on kind of the next generation pushing the frontier. Like Mary said, we are focused right now on scaling our product and the scale-up engineering that's required, and not so much on the fundamental, can we make this catalyst even better? And so they're kind of continuing that work on the materials side. We're doing the reactor and scale-up and systems side. And I think that's a natural sort of, place to be, because the applied research that we do as a startup, the time horizon has to be a lot shorter, right? We can't be doing work that is only going to pay off 3 years from now. It just doesn't make sense, because our funding cycles are only 2 years, usually, in our case for venture funding, which we are fundraising. So if anyone has money,
talk about that. Super insightful, and that really dovetails well with what David's initial answer was. Mary, Yale has numerous research collaborations with Lithos and with the enhanced weathering field more broadly. And that's all nice, and it's nice to advance science, but you as a very laser focused on profitability and scaling, can you give some examples of how the research has helped you and how it's helped advance your business?
Yeah, absolutely. So I would say this falls under 3 different umbrellas. The first umbrella is that, again, it helped establish a robust, credible footing for the field to begin, because all enhanced rock weathering was absolutely first of a kind, and no one had ever really commercialized it before. The first umbrella is just like creating a robust footing for this to all start. The second thing is that as we go and as we deploy, we learn new things around every single corner. In academia, you've got maybe a dozen little plots on small farms, which are often not working large-scale farms, as Noah mentioned. They're often like little pilot farms or energy farms or farms growing a very specific kind of crop. And so as we've deployed now in all of the major crop types in 10 different states, as we've deployed across dozens of different soil types and soil textures where this rock dissolves at a different speed, the rock behaves a little differently. There's been hurricanes across some of our deployment sites and then massive 130-year droughts. As all those things happen, you get a whole bunch of data that just was not going to be possible when you're working on a tiny little acreage of footprints or a footprint of land. And so as we've encountered all of that, it's been so valuable to be working directly with academics who have really incredible tools in their laboratories, have new techniques for analyzing data and new methods like isotopic tracers that they can apply to the challenges we see out in the field, and can really adapt that really robust sense of measurement to real world conditions that they've also never thought about before. And so that sort of feedback loop that Lithos has been a big fan of since day 0 has been so important to us as we continue to grow. It means that we are confident that even as we encounter new things in the field, that doesn't mean avoid that entire farm type, like don't deploy on this entire kind of customer. Instead, it means like, let's lean in, let's go tackle new challenges. And it means that we can, under the second umbrella, bring those boundary conditions, we would say, back to academia and share some of those. And then I would say research is great at, solving within certain boundary conditions that are given to them. So I would say that's the second umbrella. And the third one is that also as we seek to grow this field, looking for new opportunities, looking for ways of taking the technology that is already working and then applying it in more cost-effective ways, applying it in brand new parts of the world. All of these things require not just commercial attitudes, but also policy thinking and collaboration from a global network of academics. And I think YCNCC and the Yale University community and Noah and a lot of his team have been so incredible in this work. So I would say there are so many little feedback loops across the process, and from feeding first-of-a-kind real-world learnings back into academia, attempting to solve those problems, and then attempting to not just roll those little problem solutions out, but also doing this at a large scale. Those have been some things that are really valuable for Lithos. So that's important as we do our first international pilots, which we just kicked off this year. That's been important as we've expanded across many states and a larger footprint, and as we look to increase our economies of scale and bring down our costs and work with new customers who have lower price points in the first batch of customers, like all of this research becomes very important. And I think that feedback loop really is super critical so that academic funding can also be turned to real world solutions that can really matter to society at large.
Yeah.
Maybe just throw in one there. I think Mary made it sound like academics can solve a lot of problems. Large hurricanes are just really bad. It comes back to us like, hey, what do you think about large hurricanes? It's like, I don't know, Mary, that sounds pretty bad. Important to keep in mind.
Yes, I definitely didn't mean we can solve the hurricanes. Just the hurricanes disrupt some of your data collection, and then you get different fluxes out of the soil. But that was a little detailed.
If I may just chime in here. I think one of the so we've been talking about the relationship between academia and industry in a sense. I think that there are some productive partnerships that can be leveraged within the university to make progress as well. So speaking as an engineer, right, who works in part on ways to develop systems that can remove CO2 out of ocean water, right? One of the questions that we think about is, well, in the lab, you worry about. You have some sort of mimic of seawater, you put it in your system, and then you try to figure out how well it works. But in reality, if you were to deploy this, somewhere out in the field, you have to worry about working with real seawater and what happens to the Earth system when you take out large quantities of CO2 with the particular system you're working with. And so that has meant, actually, having joined Yale, that has meant that I'm now talking to people in Earth and planetary sciences who work on Earth system modeling, who work on dealing with real seawater. We had the opportunity to test real seawater from the Long Island Sound in some of our systems. And we learned a lot doing that we wouldn't have the traditional route, right? Which is everybody else is just putting, using salt water with a little bit of baking soda. No kidding. As sort of the mimic for seawater. But seawater really is much more complicated. And there are aspects beyond just the chemistry of what you're working with that you have to think about. So treating these problems as multi-interdisciplinary within the academic context is also really important. I think that's one of the sort of selling points, I think, of the center is that it makes these relationships easier.
This is great because we've achieved a little bit of spice and multiple interruptions as part of our assignment. So we want to make this dynamic, and I remind you that in a few minutes we're going to open it up to you guys for audience questions. So please think of some good ideas. Noah, I just want to. So what we've been talking about here, this idea that how research can feed back into commercial progress. The analog is entirely true too, and we've kind of alluded to it, but we sort of at YCNCC codified this into a strategy that we call research for deployment, because many of the solutions that we work on, the problems, as Mary said, can't be answered with a 1 acre plot, much less in a new lab. And Connor talked about this as well. Noah, can you talk about this idea of research through deployment and how important it is for advancing the science that we're working on?
Yeah, I think you did a great job of introducing it. If you could apply this to any number of different fields, but imagine in an agricultural system, you are going to have a real limit on what you can learn from working on something that is a 10 by 10 meter plot. That doesn't tell you how this actually affects farmers. That doesn't tell you how this is going to work in the real world. And so being able to couple with commercial efforts and have a little bit of research funds go into learning from these at-scale commercial deployments, I think is something that is going to dramatically increase how rapidly we can learn how things work. So I think it's the relatively the relatively simple way I think about this is as from a carbon dioxide removal point of view, as you have large tech companies pouring billions of dollars into this, we can take two paths. We can have one where we learn very little, and we have universities viewing that as largely a policing effort after efforts are done, or we can try to be more collaborative, know that we're trying to tackle a huge problem, and have that being something where we're learning along the way to try to ensure that we don't look back 10 years later and point out we've been on a wrong path, is the simple way of how we try to phrase this and try to have that be appealing for the folks that are investing scales of money that are massive and that could be massive from a learning point of view.
Yeah, to pipe in there a little bit. I really like what Noah said about, there's a lot that you can't learn from these small scale deployments. And I think a little bit of a spicy comment here is, when we first started Lithos and when we first started going out there and doing first of a kind deployments, and getting our first customers signed, the biggest carbon removal technology that existed in the market, it's been around now for 15 to 16 years. It's raised about $2 to $3 billion and spent most of it too. It's actually something called direct air capture. I'm a big fan of the concept. The concept is you build a big vacuum. It's very, very loud. Noah and I have visited some of these plants in other parts of the world, like Switzerland. They usually burn like energy or waste fuels to have these big vacuum cleaners that suck CO2 out of the air. That was the primary form of carbon removal. And it still is the most well-funded one today with $2 to $3 billion under its belt. But I think that they actually didn't do a great job of this concept that Toby had of research deployment. After all of that capital gone into commercial projects, they're very siloed. They're very, very closed off. They could probably do better with that, but there's like IP worries. There's so many direct air capture companies. And because of that, these companies all time have captured a total of 4,000 tons of carbon, while Lithos and the kind of technology that we are using have now captured over 30,000 tons of carbon that have been submitted and shared with customers. And that's really interesting to me. So much capital has flowed into this thing off the backs of some great academic research 15 years ago, which was like, theoretically, these vacuums could totally work. But then it gets really difficult when you're building massive vacuum cleaners, as you can probably imagine. The humidity in the air is wonky, and then like there's an ice storm in Iceland and it breaks your facility, and construction timelines are hard. Like that really should feed back into academia. There are probably challenges there that could have been tackled in some interesting orchestrated fashion and simply didn't occur. And so I would say that would be maybe a more concrete, distinct example of when there isn't research through deployment, or a wall goes up, like a Chinese wall immediately goes up after something goes commercialized. And then there's just like intense secrecy abounds and lots of investor money gets poured in. And so I would say that, to Connor's point of, he's raising right now, as enhanced rock weathering, as other forms of carbon removal seek to grow, I would look for us to do a more open pathway where there is like an open demonstration of things we don't know. Like, I've not gone through an ice storm. I hope there's no ice storms on our farms this year, and that would be awful for farmers and for us. But, as new things occur, we actually can transparently label that and then seek to find resources and start to tackle that. And I actually think that should build more investor confidence, not less. It's not always how private capital works, but I think that actually ends up being a better use of capital compared to some of the former models of yesteryear. Mild spice.
David, before we move on from this point, just as the closest thing we have on our panel to a representative from the direct air capture community, is there anything that you would like to say in response to Mary's vicious attack?
Well, my instinct would be to defend my fellow engineers under normal circumstances. I don't work on direct air capture. It's funny though, because one of the reasons I got into CO2 capture was through conversation with the CEO of the company that Mary was just talking about. I guess in a sense, all we want, the end goal of all these technologies is air, CO2 removal from atmosphere. It is. The question is whether this particular engineered system is a solution, right? And in my opinion, I think the reason these companies are having a hard time is just because of the second law of thermodynamics. The low partial pressure of CO2 in the atmosphere makes it really, really difficult to pull it out at a practical rate. this makes the argument in some sense for marine carbon dioxide removal, which is an area I'm increasingly interested in, or we've been very interested in. So in the ocean, you have 100 times more CO2 than in air, and so that can maybe take care of that problem to some extent. Although you still have to deal with pumping lots of seawater. So all to say, I think engineered systems have a role to play, but you have to find the right application, the right outlet.
So some folks may not know this. It's actually, as Yale professors in the home of Gibbs, it's actually in our contractual agreement to at least once a day bring up thermodynamics and Gibbs. It was good of David to do that.
The entrepreneur that I think Mary was referring to, David Keith, is now at University of Chicago, but he is coming to Yale as a visiting scholar at David Quabi's invitation this fall. So if you're in New Haven, there will be a big public lecture, and we'll have an opportunity to talk about this more. But Connor's been interrupted 3 times now, so go ahead.
Well, as someone building engineered systems, although they're not direct air capture, I'll say I think that research through deployment is not equally easy, or for different types of technologies, right? And I think for something like direct air capture, and even for the type of technology that we build at Oxalis, it's more difficult, right, than the natural solutions, because it's pretty CapEx intensive. And the question is, okay, what is the minimum scale that you need to build to inform the research, right? And ultimately, we want to build 100 megawatt deployments. That would be the scaled solution. Obviously, 100 megawatt deployment could be $100 million plant, right? Which is not unnatural for a chemical plant, but that's a lot of capital, right? And you don't want to build a $100 million plant that isn't economical, or that has technological failures. And the banks that are financing that don't want any tech risk either, right? So how do you get there? To eliminate all the technology risk, have high confidence that it's an economical plant, and that everything's going to go to plan, right? It's not easy, right? But we're trying to map out a deployment schedule where we can learn, right? And that those cycles of iteration are rapid and not too expensive. And I think that's where things like direct air capture, and in our case, CO2 electrolyzers, should really learn is, okay, what makes sense for a deployment schedule where each time you can iterate and you're not spending too much capital each time, and finding the right capital partners, the right customers, ideally, that pay for some of that is really critical.
Well said. Before we go to audience questions, I want to circle back to our topic here of investable companies. And before I do not want to give the impression that the university people on the panel are also not trying to raise money. We raise money from philanthropy, corporate philanthropy, traditional philanthropy, and we need these industrial collaborations, which we'll never be able to pay for with philanthropy, to answer the questions that we're seeking to solve at scale. But there's no money in these commercial projects to fund research to speak of, so we need philanthropy to fund the research alongside of them. But back to the companies. Both Mary and Connor are in fundraising mode in kind of different ways, and maybe I would love each of you to tell us where you are now, what you need, what kind of capital you need, what are you going to do with it, what will it get you to? Maybe Connor first, since you're kind of in the active throes of the equity capital fundraising.
Yeah, absolutely. Yeah, we're raising a seed extension round right now, targeting a $7 million round, mostly from venture investors, but also looking at family offices. And really, what we're doing with the money is to scale from our pre-pilot that we've built in our lab that we just brought online last month. That's a few kilowatts. So it's like kilograms of fuel per day. Scaling that to a customer deployment, and so that's going to be partially paid by the customer, partially funded through the company. So that's what we're raising for, and that's going to be about a 10x size increase from where we are today in our facility, and deployed at the customer site using real CO2 from an industrial process, converting it into fuel on site. So we're really excited about that. It's going to be a big push for us, and a big journey ahead.
Awesome. Yeah, on our side at Lithos, we have raised a lot of our capital from mostly software VC, so Union Square Ventures, Greylock Partners, Bain Capital Ventures, so a little different from many other hard tech companies, but the reason for that is we really see ourselves as a platform. We don't need to own every single part of it. We certainly don't own farms and quarries. What we really funnel our funding into is developing the platform itself for the science, the research, the measurement, and the validation of a lot of this behavior at scale. And so overall, we're not actively fundraising at the exact moment, but we are always looking for great partners who are really thinking about that long-term vision. We know that enhanced rock weathering, this technology that was really, founded out of a lot of research at Yale, can capture something between a quarter to a third, maybe, depending on your scenario, of the carbon dioxide that we regularly emit in society today. That's amazing. And you really need a platform to help scale that and make that possible. And not just America, where Lithos is live today, but in other places. So, always looking for partners who are interested in how does this look in agricultural settings across the world, like Southeast Asia or South America? How does this look as we bring down costs in America and work more deeply within agricultural networks and with the USDA? So for folks who are interested in that kind of application, we would love to chat. And we really are so grateful to the Yale ecosystem for the strong start we got and for all the continued research that enables the growth of this across the world.
And Noah, just to close the loop on this final topic, I know you think a lot about, even though you're a scientist, you think a lot about money and about how to just the cost of capital for carbon removal companies. Like, how can carbon removal companies scale when, what are the challenges they're facing, and what are some solutions that you see that you think about?
Yeah. So I think one way is something that I've been thinking a lot over the last year. In many cases, for different types of carbon dioxide removal, just financing the debt can be 20% of the total project cost. That's the problem, is we're putting large amounts of money into driving carbon dioxide removal, and it can be that the only ones that are making money on this is the folks actually doing the financing for the project. So that's a huge problem. And I think there are lots of ways in which I think there's no single answer to that for different companies. Is going to depend. But I think thinking about novel, as folks, everyone with different background, we need new thoughts into that. Thinking about novel ways for things that have a positive impact in the environment to have financing that is at a lower amount. But also one of the things that we really think about is how can we change protocols to ensure that we still have something that is a robust removals, a robust product, without having necessarily the same financing requirements, the same need for debt in that. How can we have more money up front to make sure that more of the money actually goes to the projects? So I wish Toby might have imagined I had a witty answer to that, but I think in a lot of cases we really need to be thinking out of the box in a large range of ways to just ensure that more money that's supposed to be driving carbon removal actually goes into the project.
And to that end, we've had a number of meetings with finance experts and trying to brainstorm this problem and try to help the project developers, which are both startup companies but also agricultural incumbents, work through co-op structures and just find lower cost of capital deploying climate mitigation. Because we do want the investors to make money, but we don't want them to be the only people that are making money. All right, do we have some questions? Awesome. Yeah, let's go. Do you want to introduce yourself?
Sure. Catherine Manzo. Hi, Yale alumni. Curious about the tech transfer process and licensing from the university. It doesn't have to be all of you, but somebody speak to, is it kind of standard? Can you negotiate that? I imagine there's some impact to your unit economics of actually commercializing your technology and building the business.
Sure, yeah, I went through the licensing process a couple of years ago. And yeah, I think Yale has done a really tremendous job over the last few years modernizing the process, I guess you could call it. With Yale Ventures, they have a template agreement now that, has template terms you can sign on to license, Yale technology. In my case, we patented the core material discovery at Yale. I was one of the inventors on that, and then we, exclusively globally licensed it to Oxalis. And yeah, we did negotiate parts of the template. That's probably all I should say. But for the most part, I think they like the template as it is, and that does minimize the sort of effort and the cost to the companies. And I think for most business models it works. But yeah, it's a combination of equity and revenue splitting. I think having that template has really made things a lot easier.
I can just add to that, and this is a event hosted by Yale Ventures in large part, so no need. But that's not why I'm being positive. I think having been here for a while, I would agree with it's huge change from when I first got here to what it is now, and you could say it's negotiation is one way to look at it, but I think in many ways it's a conversation to think about what is actually going to work for the company, and instead of thinking about it as fitting a single protocol, a bunch of people that have a ton of amazing experience that actually want things to get out into the world, and I think that's we from the folks that at different universities have been able to talk to feel really lucky to have something that is relatively straightforward, but is a conversation to what can we do to actually get this in a place that actually is going to be investable, is going to succeed, and not everybody certainly gets to be able to say that.
And as someone new to Yale, I do know from the outer world that you should be proud as an alumna. Yale is notoriously innovation friendly in terms of IP and all of that. And it's a testament to Josh Jabal and his team at Yale Ventures, so you should be proud.
Choice of two questions. One's about, it's up to you guys. One's about academic opportunities or needs for pre-commercialization customer discovery. To what extent does the academic group get involved, or should? The other one would be about de-risking and trying to shave that 20%, whether it's through better credit verification or other forms of de-risking that can be on the academic side. One thing is being able to audit the results. I'm just wondering if anybody has any thoughts on either of those, I suppose.
You want to take that?
Did that make any sense?
Yeah, I mean, I guess on the first one on the financing one is one that we're really passionate about right now. I think and it's thinking about this from one is I think pulling from non-traditional sources more and as you move that, I think that one of the roles that universities can do is to have something where you can actually work with things that are traditional audits, make it available to have, and this isn't just something Yale, the broader academic community can have something to provide a conversation to ensure that we can actually get capital at lower rates flowing from that. And some of that will be as like a concrete example from that is right now we have been thinking for the agricultural space, you can bring in something at 4.5% through CoBank, and talking to CoBank, having folks there talk to folks that are in the academic community, connecting with people that are traditional customers in the agricultural space is a way where I think something like that is possible.
Yeah, in addition to working through existing commercial structure, which I think is a great strategy, I mean, the other idea that we've been thinking about and talking about, and there's at least a few examples out in the world, is concessionary capital that's backstopped by philanthropy. You can't, the risk is not going to dissolve. I mean, it's there, and somebody has to take it. And there are structures that have been sort of developed on a trial basis that with, JP Morgan or incumbent financial institutions, backstopped by philanthropy to provide this kind of working capital for carbon removal companies and project developers. And that's, I think, a hugely high leverage use of philanthropic capital. And so if anyone's interested in that, we'd love to talk about it. I think when your first question was, do academics get involved in customer discovery?
Could they, should they, under what conditions?
I think we do all the time. I mean, for example, at YCNCC, we have a project that's funded by Bezos Earth Fund. We won a $2 million grant of NOAA and a couple other professors from Earth and Planetary Sciences to use machine learning to develop open source tools for marine CDR measurement, reporting, and verification, so to measure the carbon removal through some of the solutions that David Quabi is working on, for example. And we just hosted a workshop first week of May that was effectively a customer discovery workshop. We had 15 project developers here on Yale's campus listening to a few talks about what we're trying to do, and then we broke out and got their feedback on the idea. And then eventually we're going to need them to trial the tools. So I think that's a really important strategy for advancing the science that we're working on. I don't know if anyone else has any other comments. I saw at least one other hand back there. Yeah, back row.
Hi, yeah, thanks. I have a couple of quick questions. One is, when you think about folk technology and kind of moving from, pilot to deployment, there's a lot of challenges with the Valley of Death, trying to kind of find the product that is going to scale most quickly. But often, SBIR funding or other types of funding could lead you into a different technology direction. How have you squared that, or have you had to square that, Mary or anyone on the panel? And the second question was just briefly around kind of the power of Yale in innovation in Connecticut as kind of an innovation hub and kind of capturing kind of the energy, of the Yale Ventures to scale for important reach in this state.
Mary, I don't know if you have thoughts on that.
Yeah, I can start. Thanks so much for the question. I think you bring up a great point. The Valley of Death is a really important thing for any industrial company like the ones that Connor and I run. I would say that it's like a very careful dance where you have to make sure you raise enough equity funding for like the first version of your facility and the first build up. You really need to be incredibly aggressive about hitting certain milestones and goals so that you've proven out enough. You can go out and raise more equity capital if that's what you're aiming for, or you can aim for getting customer contracts that will pay you and having modeled that with enough risk buffer in as well, because things always go a little sideways. So I would say it's really challenging. One of the best things to focus on is really just execution there, not just like financial instruments, but execution. And I think that that is one of the areas that a lot of companies end up like flying or falling, depending on whether they can get those technological risks to be resolved in the appropriate amount of time. But I think it's a really, really great point, and it's a challenge across all hard tech industries today.
And your second question, Connecticut has an incredible innovation ecosystem. Connecticut Innovation, Yale Ventures, Yale University. Connor, I believe, is a poster child of that, and the beautiful brand for Connecticut. I mean, do you want to talk about how it's been to like build a company in the New Haven area?
Yeah, I mean, when we started the company and we were looking at, where do we want to be, it's about talent, facilities, and support network, and we chose to build here in Connecticut. Connecticut Innovations is one of our investors, and they've been phenomenal to have on our team, connecting us with resources and other companies in Connecticut. We actually have had a collaboration with one of their other portfolio companies that works in a similar space, Nimbus Power Systems, and so it's been great to be here. And there's actually a strength of electrochemical talent here, starting from kind of the fuel cell industry that's been here for decades, and we've pulled talent from that. We've been able to attract talent from two of our hires from Boston, one from New York City. But yeah, building community here is really important because I think the more startups we can have here, the easier it'll be to continue bringing talent. But being here in Connecticut, and I think if I had a call to action for Yale or Yale Ventures and the Connecticut ecosystem, would be to build these continue building the ecosystem for companies to be incubated here, right? Places like Climate Haven, which is where we that was the first place we kind of went off campus that gave us mentorship, a space to be, to hold our first pitches and meetings and even prototyping. And so I think if we can build out that type of space to have companies, promising companies, really think about staying here. I think that is really what's missing, I would say, is like more of that community facility incubator space.
Perfect note to end on. Thank you for that question and for the great testimonial, Connor. Just want to thank you.